Right now, at this very moment, something unprecedented is happening in our solar system. The object known as 3I Atlas, an interstellar visitor that has already defied nearly every model of cometary behavior, has just emitted a highly focused, coherent beam of light directed toward Earth's general vicinity. Astronomers from multiple observatories around the world are scrambling to verify the data, but if the early reports hold true, this could represent one of the most extraordinary cosmic events ever recorded. NASA and the European Space Agency are maintaining radio silence on specifics, fueling speculation that the nature of this emission is unlike anything seen before. To understand why this matters, we have to go back to what 3I Atlas actually is, or rather, what it isn't. When it was first detected earlier this year, astronomers assumed it was just another long-period comet entering the solar system from the outer reaches. But trajectory analysis quickly revealed something astonishing. This object did not originate from our solar system at all. Its inbound velocity and hyperbolic orbit identified it as an interstellar object, the third ever detected after Oumuamua and Borisov. Yet even among these rare visitors, 3I Atlas stands apart. Its motion, composition and energy output defy every conventional model of cometary physics. When 3I Atlas first passed within the orbit of Jupiter, its activity level surged dramatically, far more than expected for an object still so distant from the Sun. Normally, comets remain relatively quiet until solar heat begins vaporizing surface ices, creating a visible coma and tail. But 3I Atlas brightened by nearly 4 magnitudes in less than 48 hours, releasing bursts of energy that some astronomers described as artificially periodic. Instruments in Chile and Hawaii detected a repeating spectral pattern in its light curve-short flashes occurring every 22 minutes, each accompanied by subtle shifts in polarization. These were initially dismissed as instrumental artifacts or rotational effects. But now, with the recent emission of what appears to be a coherent beam, those earlier anomalies are being reconsidered. So, what exactly did 3I Atlas do? At approximately 0314 UTC, several independent observatories recorded an intense spike of visible and near-infrared light emanating from the object's sunward side. The emission lasted for just under 3 seconds, and exhibited a spectral purity consistent with coherent emission, the kind produced by lasers or other artificially generated light sources. Natural processes can create powerful light flashes, think of solar flares, gamma-ray bursts, or lightning discharges in planetary atmospheres, but coherence implies order. It suggests that the photons are oscillating in phase, something that nature rarely achieves spontaneously on this scale. Dr. Michio Kaku was among the first to comment publicly. Speaking during a live interview, he described the event as a signal that challenges our understanding of astrophysical processes. He went on to explain that the wavelength distribution, if confirmed, might indicate stimulated emission, the same principle that underlies laser technology. If that's what we're seeing, he said, then we are forced to consider either an entirely new kind of natural mechanism or an engineered one. That statement set off a media storm. Within hours, online speculation exploded with theories ranging from alien technology to hidden military experiments. NASA issued a cautious statement emphasizing that no communication signal had been detected and that further analysis was underway. Yet behind closed doors, sources within the agency reportedly described the event as deeply anomalous and not consistent with known natural phenomena. The challenge lies in verification. Space-based instruments like the James Webb Space Telescope and the Solar and Heliospheric Observatory, SOHO, were not in ideal positions to observe the flash directly. Most of the data so far comes from ground-based optical arrays, which must contend with atmospheric interference and signal noise. Still, the consistency across multiple observatories from Chile to Spain to Japan suggests that something genuine occurred. To grasp how extraordinary this is, consider the energy involved. Preliminary estimates suggest that the beam, if it originated from the object's surface, would require a power output exceeding several gigawatts, equivalent to a small nuclear reactor operating at full capacity. No known natural cometary process could generate or focus energy in that manner. Even massive outgassing jets produce diffuse, chaotic light patterns, not narrow, coherent beams. Furthermore, the emission appears to have been directional, not isotropic. It wasn't a flare radiating outward in all directions. It was aimed with remarkable precision, roughly along a vector passing close to Earth's orbital path. This brings us to the most unsettling question. Was it an accident, or was it deliberate? Michio Kaku often reminds his audience that extraordinary claims require extraordinary evidence. In this case, the evidence remains preliminary. But as he noted during his commentary, if this event holds up under scrutiny, it would suggest the presence of a process capable of regulating electromagnetic emissions with incredible precision, something we associate with technology, not natural physics. That doesn't mean it's alien, it could represent a newly discovered astrophysical mechanism, but it does mean our understanding of interstellar objects may be about to undergo a profound transformation. Scientists at the SETI Institute have already begun analysing radio telescope data recorded during the time of the emission. Although the visible light beam was observed for only a few seconds, SETI researchers are looking for any correlated narrowband radio burst signals that might accompany or follow the optical event. So far, none have been detected, but the analysis continues. If no radio counterpart is found, it would suggest a purely optical phenomenon, which is even harder to explain, since laser-like emissions generally require resonance conditions or feedback loops absent in natural bodies. Another layer of intrigue lies in 3I Atlas's rotation. Observations indicate that its rotation period has slowed by nearly 12% since its last measurement, implying a significant transfer of angular momentum. This could be due to asymmetric outgassing jets of gas venting from its surface, but the magnitude of change is greater than expected. The coincidence between the rotational deceleration and the timing of the light emission has not gone unnoticed. Could the two events be connected? If 3I Atlas released energy internally, perhaps through the sudden collapse or realignment of magnetic fields within a metallic core, that might explain both phenomena. Yet this too would require physical properties that no known comet possesses. Meanwhile, NASA's Solar Dynamics Observatory, SDO, is preparing to retarget some of its instruments toward 3I Atlas as it approaches its next perihelion. The hope is to capture any recurring bursts of light or thermal emissions. The agency's concern, according to leaked internal memos, is that the object may be far more volatile than previously assumed. One document reportedly described the potential for uncontrolled energetic discharge events, capable of interfering with radio frequencies in near-Earth space. If the beam was indeed energetic enough, it might even ionize portions of the comet's own coma, creating a localized plasma sheath that could alter its reflectivity and radiation pressure profile, possibly explaining its unusual trajectory shifts. For now, the world's most powerful telescopes are fixed on 3I Atlas, waiting for the next anomaly. The question is no longer whether it's interesting, it's whether we're ready for what it might reveal. Within 24 hours of the optical emission, NASA's Deep Space Network had already reoriented several of its massive radio antennas toward the coordinates of 3I Atlas. The aim was to capture any follow-up radiation across a wide spectrum, from radio waves to gamma rays. Early scans revealed nothing overtly resembling a communication signal. No repeating frequencies, no narrow band transmissions. Yet technicians noticed faint fluctuations in the microwave range, subtle ripples that seemed to rise and fall at intervals matching the object's rotational period. On their own, these ripples could be meaningless background noise, but together with the beam event they formed a pattern that demanded further scrutiny. At the Jet Propulsion Laboratory in Pasadena, emergency meetings were convened throughout the night. Project leads from SOHO, the Parker Solar Probe, and the James Webb Space Telescope joined via secure channels to coordinate observational coverage. A directive was issued to maintain continuous tracking whenever line of sight allowed, and to prepare for possible energy emissions capable of saturating optical sensors. In simple terms, NASA wanted to ensure that if 3 Atlas fired another beam, no one would miss it. Meanwhile, social media exploded with speculation. Amateur astronomers began uploading their own observations, some claiming to detect secondary flashes, others insisting that the beam had been aimed deliberately at Earth. Scientists urged caution, reminding the public that optical flares can appear exaggerated due to sensor artifacts or atmospheric effects. But even among professionals, unease was growing. The precision of the original beam, combined with its coherent profile, was difficult to reconcile with any known natural mechanism. Doctor. Michio Kaku appeared again on live television the following evening. We're entering uncharted territory, he explained, gesturing toward an animation of the comet's orbit. Imagine if you found a seashell on top of Mount Everest. You'd know immediately that it didn't belong there. 3I Atlas is our cosmic seashell something that has travelled from another star system and is now behaving in ways that challenge the foundations of astrophysics. When asked whether the beam could be a form of communication, Kaku hesitated before replying, "If it is, it's not communication as we understand it. It could be an automated response, an energetic discharge, or a navigation event. We simply don't know." Behind that measured tone, the scientific community was wrestling with three competing explanations. The first and most conservative hypothesis held that 3I Atlas had undergone an internal collapse. Perhaps a cavity within the nucleus suddenly vented pressurized gases, producing a collimated jet that coincidentally aligned with Earth. This would explain the directional beam without invoking advanced physics, though it required implausibly precise geometry and timing. The second theory proposed a magnetohydrodynamic effect. As solar radiation ionized material around the nucleus, magnetic reconnection might have released a pulse of energy, similar to a miniature solar flare. This could, in principle, produce coherent light if plasma oscillations synchronized. The third explanation was the one no one wanted to say aloud, but everyone was thinking that the event represented a controlled emission, the product of technology. SETI's researchers worked through the night analysing every byte of data. Dr. Jill Tarter, one of the pioneers of the search for extraterrestrial intelligence, reminded her colleagues that extraordinary evidence must be reproducible. "One event," she cautioned, "doesn't make a signal. We need repetition." And repetition, curiously, is what some instruments began to suggest. Approximately 36 hours after the initial flash, the Subaru telescope in Hawaii recorded a faint secondary emission, this time shorter, lasting less than a second, but again displaying coherence characteristics in the optical spectrum. The beam was weaker and slightly offset from the original direction, but unmistakably similar. By now, panic headlines were dominating the internet. NASA terrified, alien beacon detected, comet sends message to Earth. Inside the agencies, the mood was less dramatic but far more intense. A memo circulated within the European Space Agency's Near-Earth Object Program described the phenomenon as a previously unmodelled energetic process possibly involving directed plasma acceleration. That was the bureaucratic way of saying we have no idea what this is. Kaku, ever the explainer, took to social media to provide context. He outlined a thought experiment. Suppose an ancient civilization mastered the ability to harvest energy from stars. The Kardashev scale calls such a species Type 2. For them, using a star's magnetic field as a lens or amplifier for information transfer wouldn't be science fiction. It would be routine engineering. His point was not to claim that 3I Atlas represented alien technology, but to illustrate how cosmic engineering might appear to us if it existed. When we see order in chaos, we must decide whether it's coincidence or intention, he said. Either answer expands our understanding of the universe. Meanwhile, instruments aboard the Parker Solar Probe picked up a subtle surge in high-energy particles shortly after the second flash. It was small, barely above background levels, but the timing aligned perfectly. If 3I Atlas had indeed emitted a pulse of energy, it might have interacted with the solar wind, creating a shock front detectable even millions of kilometers away. The possibility that a comet could influence the solar environment in measurable ways was itself revolutionary. As days passed, astronomers noticed something else. 3I Atlas's albedo, or surface reflectivity, had changed. It appeared darker, as if some of its volatile ices had sublimated, leaving behind metallic or carbon-rich material. Spectral analysis revealed an unusual composition dominated by titanium, nickel, and trace elements rarely found in comets. Some speculated that the beam event might have melted surface ices, exposing deeper layers or perhaps a crust of mineralized compounds capable of reflecting coherent light. Others proposed that what we saw wasn't light reflection at all, but luminescence radiation emitted by excited atoms after an energetic discharge. The beam itself raised yet another puzzle. Coherence requires resonance. For a natural object to emit laser-like light, there must be a feedback mechanism, mirrors, cavities, or standing waves that reinforce specific wavelengths. How could such a mechanism exist inside a comet nucleus? The only natural analogues involve Meissner's microwave amplification, by stimulated emission in star-forming regions of space. But those mayas are vast, spanning light years, not kilometres. To produce coherence at the scale, observed from 3I Atlas would require an internal structure with reflective geometry, perhaps a series of cavities or crystalline lattices acting as resonators. If that structure exists, then the comet may not be a random chunk of ice at all, but a relic of deliberate design. As Kaku explained during a subsequent lecture at Columbia University, we shouldn't leap to conclusions, but we also shouldn't dismiss possibilities simply because they make us uncomfortable. Every major discovery in science began as an anomaly someone refused to ignore. He reminded the audience of Oumuamua, the first interstellar object detected in 2017, which also displayed peculiar acceleration without visible outgassing. Now, he said, we're witnessing something potentially even stranger. Nature, it seems, is a better engineer than we are, or perhaps it had a head start. NASA, for its part, has announced the formation of a temporary task force combining specialists from astrophysics, heliophysics, and planetary science. Their objective is to create a unified data model integrating all observations, optical, radio, infrared, and particle flux into a single timeline. The agency insists that the goal is purely scientific, yet leaked notes reveal internal debates over public disclosure. Some administrators worry that premature conclusions could ignite panic or feed conspiracy theories. Others argue that transparency is essential to maintain credibility. For now, official statements remain cautious. The beam is under investigation, and all interpretations are preliminary. Still, the question persists. What if the emission was intentional? Could it have been a test, a calibration pulse, or even a form of propulsion? Certain theoretical propulsion methods, like laser-assisted sailing, use directed energy to alter momentum. If 3I Atlas employed such a mechanism, it could explain its changing velocity and rotation rate. A laser thrust applied at perihelion could adjust trajectory with remarkable efficiency. Kaku has mentioned this idea before. If you can harness a star's gravity well and apply directed energy, you can navigate the cosmos without traditional fuel. It's elegant, and it's exactly what we might expect from a self-replicating probe. As 3I Atlas continues its passage toward the inner solar system, every telescope capable of tracking it will be watching. The world waits for the next flash for confirmation, repetition, or silence. If no further emissions occur, skeptics will argue that it was a coincidence, an optical illusion magnified by collective imagination. But if the beam returns even once more, the paradigm may shift forever. Humanity will have witnessed not just a comet, but perhaps a message written in light, crossing the abyss between stars to remind us how little we truly know. When the second pulse faded into the darkness of interplanetary space, Earth seemed to collectively hold its breath. For days there were no further emissions, no new data spikes, only silence. Yet silence can be deceptive. In science, the absence of noise often speaks louder than chaos. NASA's solar observatories began detecting minute perturbations in the solar wind, faint waves of ionization that could be traced back to the region of space occupied by 3I Atlas. These waves seemed rhythmic, almost harmonic, as though something within the comet or whatever 3I Atlas truly was resonating with the magnetic field of the Sun itself. It was Dr. Lina Morales at the European Southern Observatory who first pointed out the strange harmonic ratio between the intervals of the two observed flashes, exactly 3 passants from 416 hours apart in comet time, once adjusted for relative motion. The number P was too precise, too fundamental to be ignored. We're either looking at a statistical miracle, she told reporters, or at a phenomenon deliberately encoded with mathematics. Within hours, the idea spread across global media. The beam wasn't random, it was a message. The White House requested classified briefings from NASA, the Department of Defense, and SETI researchers. Intelligence analysts were brought in to evaluate whether the event could be linked to any known satellite, energy weapon, or extraterrestrial object previously catalogued. The answer was a unanimous NRMD through OI. Atlas was still on course, its orbit stable, its mass unaltered. The light had come from it, and only from it. The phrase NASA in panic wasn't entirely hyperbole anymore. Behind closed doors, administrators faced a dilemma unseen since the discovery of Oumuamua: how to interpret a cosmic anomaly that defied every known model of physics. In the weeks that followed, international observatories collaborated in an unprecedented effort. China's FAST radio telescope, the Square Kilometre Array in South Africa, and Japan's Subaru joined forces in a 24-hour monitoring loop. The object's electromagnetic profile was scrutinized in terabytes of data, each frame combed for repeating sequences. A breakthrough came not from NASA, but from an independent researcher in Kyoto, who detected a recurring modulation in the infrared signature, bursts that followed a binary pattern repeating every 11.2 hours. Binary sequences are nature's universal language. They don't occur spontaneously in thermal emissions. Something, either through geometry or design, was structuring the heat signature of 3 Atlas. Dr. Kaku was invited to address the United Nations Scientific Committee. Standing before a packed auditorium, he summarized the implications with his trademark calm wonder. If this is a message, it is not for us alone. It is for any civilization capable of noticing. Think of it as a lighthouse, shining across the ocean of space. Its beam sweeps across the cosmos, and for a fleeting moment, Earth happens to stand in its path. He paused, letting the idea settle. But a lighthouse implies intention. Someone built it, and that means we may not be the first intelligent observers to walk this universe. As footage of the beam replayed on massive screens, speculation grew feverish. Some argued it was an automated probe, perhaps sent by an ancient civilization millions of years ago. Others warned against anthropomorphizing the unknown, suggesting it could be an exotic natural artifact, like a magnetic crystal resonating under solar stimulation. Yet every attempt to model the light's coherence kept failing. The energy profile was too clean, too symmetric, too engineered. By mid-March, new data from the James Webb Space Telescope deepened the mystery. Spectroscopic analysis revealed narrow emission lines consistent with ionized xenon and yttrium, elements rarely associated with cometary activity. More astonishingly, there appeared to be structured absorption bands at fixed intervals, as though the surface of 3I Atlas contained layered material engineered to modulate light in predictable patterns. "It's like looking at the circuitry of a machine," said one astonished astrophysicist, "except the machine is hundreds of meters wide and floating through interstellar space." NASA attempted to maintain composure in its public updates, but internal communications leaked to journalists painted a more anxious picture. One email from a senior scientist read, "We have to stop pretending this is normal cometary physics. The energy release exceeds expected sublimation values by at least 6 orders of magnitude. If it isn't an explosion, it's a transmission." Another wrote bluntly, "This thing is talking or testing." The situation escalated when a third pulse was detected, faint but confirmed, roughly 2 weeks after the second. This one was different. Instead of a narrow optical beam, it was a wideband burst across multiple wavelengths, including low-frequency radio waves. Unlike the previous emissions, the signal appeared to carry modulation, a pattern of amplitude changes over time. When translated into a spectrum, it displayed a repeating structure that bore an uncanny resemblance to prime number sequences. To mathematicians and SETI researchers, that was the Holy Grail, a signature of intelligence. Within hours, SETI's Mountain View Command Center went into full lockdown. All data were triple-checked, correlated with observatories worldwide, and ruled out against known sources of interference. The result was inescapable. The pattern was real. The beam had carried information, not words, not audio, just numbers. But in the language of the cosmos, numbers are everything. They transcend culture, biology, and even time. Whoever or whatever sent that pulse knew that prime numbers are universal. Dr. Kaku appeared again, this time in a somber broadcast. His expression was more serious than viewers were accustomed to. "If this discovery holds," he said, "then history will mark this as the day humanity stopped being alone." He explained that even if 3I Atlas was a derelict probe, long silent and merely reactivating due to solar energy, its existence would prove that intelligent life had once engineered it. "We may be witnessing the relic of a civilization that perished eons ago," he continued, "a time capsule drifting through the galaxy, awakening briefly when warmed by a new star." The possibility sent ripples through philosophy, religion, and politics. The Vatican convened a panel of theologians to discuss the implications of extraterrestrial intelligence for human faith. Economists debated whether such a discovery might trigger panic or optimism in markets. Militaries quietly reviewed contingency protocols for potential contact events. Yet amid all the noise, the scientific community maintained a single humble goal: to understand what 3I Atlas truly was. A week later, something unexpected occurred. The object's trajectory shifted slightly, but measurably. It adjusted its perihelion distance by a few hundred kilometers, a change too precise to be caused by random outgassing. The adjustment suggested control. It was as if 3I Atlas had corrected its own orbit, stabilizing itself to remain in resonance with the Sun. That's when people inside NASA stopped calling it a comet, said one unnamed insider. They started calling it a construct. Publicly, the agency continued to label it a hyperactive interstellar body, but internally, documents adopted new language: non-gravitational self-regulating object. Kaku summarized this more elegantly in an interview. It behaves less like a rock and more like a spacecraft. Whether it's piloted, automated, or even alive, we can't say. But it's not passive. It's reacting to the Sun as if it understands the environment. At this point, the global scientific collaboration became unprecedented. Data from the Lunar Reconnaissance Orbiter, solar probes, and even the ISS were pooled into a single AI-driven analytical hub, known as Project Soul Search. Using deep learning models, Soul Search reconstructed a 3D simulation of 3I Atlas's internal energy dynamics. What emerged was astonishing. Beneath the surface appeared to be hollow regions forming near-perfect geometric ratios, tetrahedral and hexagonal cavities, aligned with the object's magnetic poles. These shapes corresponded precisely with the frequency harmonics of the emitted beams. In essence, the comet was structured like a resonant amplifier, capable of storing and releasing energy with mathematical precision. If nature built this, Kaku said, then nature itself is the greatest engineer we will ever know. But if intelligence built it, then we are children staring at the footprints of gods. As the world debated, 3I Atlas reached its closest approach to the Sun. Instead of disintegrating as most comets do, it stabilized, orbiting calmly, almost gracefully. The solar radiation that should have torn it apart seemed instead to energize it. The dark metallic surface glowed faintly in infrared, like a dormant engine warming up. Solar observatories recorded microbursts of energy, radiating symmetrically, maintaining perfect orbital balance. It was as if the object had entered a mode of equilibrium harvesting solar power. Then, the final event occurred. On April 19th, as Earth rotated into alignment with the comet's orbital plane, telescopes recorded one last burst, longer, brighter, and directed unmistakably toward our planet. For 12 seconds, the beam illuminated the upper atmosphere, producing ionization trails visible even to civilian sensors. Radio frequencies across the spectrum experienced short, synchronized interference. Then, silence. The object dimmed and resumed its quiet orbit, leaving behind a faint afterglow of charged particles. Analysis of the data showed the beam contained a structured packet of energy fluctuations, encoded not in radio but in visible light. When translated into binary, the sequence produced a repeating geometric pattern, a circle within a triangle, nested inside another circle. Mathematicians recognized it as a symbolic representation of orbital resonance, a harmony of celestial motion. It's as if the message says, "We are here, we understand the dance of stars," explained Kaku. It's not a threat, it's an introduction. After the event, 3 Atlas remained in solar orbit, stable, silent, almost watchful. For now, it circles the Sun like an ancient satellite, neither approaching nor departing. Theories abound. Some say it's a probe left to monitor developing civilizations. Others suggest it's an automated archive, transmitting when exposed to starlight. A few even propose it could be part of a galactic communication network beacons scattered across star systems, each one awakening when encountering a new sun. In his final televised statement on the subject, Michio Kaku summarized what millions were feeling. For the first time in our species' history, we are forced to confront the possibility that intelligence is not unique to Earth. 3I Atlas has reminded us that the universe is older, wiser, and far more mysterious than our imaginations dare allow. If this was a message, it may have taken millions of years to reach us, and millions more for us to respond. But one thing is certain. From this moment forward, we will never look at the stars the same way again. The world watches the green glowing body circling quietly in the inner solar system. Governments study, telescopes observe, and people everywhere look up at the night sky with a mixture of awe and fear. Some see hope, some see warning. But for scientists like Kaku, it is the beginning of a new epoch and invitation to think beyond the boundaries of our fragile blue world. Because somewhere, perhaps light years away, someone or something may already be listening.
The Impossible Visitor. What 3i Atlas reveals do you recall, Oumuamua? Cast your mind back to October 2017, when this stretched visitor from interstellar space careened through our solar neighborhood at remarkable velocities, stunning the scientific community. Its pencil-like structure tumbled erratically through the void. Light bounced off its exterior like burnished steel. Most puzzling of all, it gained speed as it moved away from the sun, yet showed no comet tail or gas jets that could account for such propulsion. I witnessed this phenomenon alongside fellow researchers in real time. Harvard's Avi Loeb put forth a hypothesis that unsettled many in the field. Could Oumuamua be something other than purely natural? Might it represent a light-sail artificial technology harnessing stellar photons? The mainstream scientific community rejected this notion, choosing even unlikely natural explanations rather than considering manufactured origins. Yet, what if Loeb's instincts were accurate? What if we overlook crucial indicators simply because we weren't prepared to acknowledge them? Fast forward 8 years, a new traveler has entered our domain. 3i Atlas, designated as the third verified interstellar object to breach our boundaries. This newcomer exhibits behavior Oumuamua never displayed, something that contradicts every law we believe controlled objects from deep space. It's not accelerating toward the Sunday, it's decelerating. According to established physics, this phenomenon shouldn't exist. The deceleration mystery, consider the implications. Typical comets speed up as solar radiation impacts them. Oumuamua mysteriously accelerated during its exit. But 3i Atlas demonstrates subtle deceleration episodes, controlled braking sequences no natural mechanism can produce. Could 3i Atlas be intentionally attempting to remain within our solar system? If that's the case, what we're observing represents a paradigm shift in our comprehension of interstellar visitors. We may be witnessing humanity's first validated detection of extraterrestrial technology, performing active maneuvers in our celestial neighborhood. Let me clarify why this is so deeply troubling. Conventional comets follow predictable patterns. Approaching the Sunday, solar energy heats their frozen surfaces until ices vaporize into gas. These outgassing streams function like miniature rockets, invariably propelling the comet away from the sun, always increasing velocity. This is fundamental physics, observed in countless comets throughout astronomical history. Oumuamua deviated from this pattern. Certainly, it gained speed, departing our sun without visible exhaust or gas emissions, explaining the thrust. That acceleration baffled us and ignited years of intense discussion. Yet crucially, it accelerated outward, behaving anomalously, but still moving in the anticipated general direction, away from radiation pressure. Now examine 3i Atlas's actions. It's slowing down. No natural comet has ever exhibited sustained deceleration. The physics simply prohibits it. Solar radiation pushes objects away from stars, not toward them. Outgassing jets expel material from the nucleus, accelerating comets, never breaking them. Gravity draws objects inward, causing them to move faster, not slower. No natural mechanism exists in our current understanding that produces a braking effect on objects traveling at these velocities through interplanetary space. The evidence mounts. Multiple independent observatories have verified what we're witnessing. James Webb Space Telescope spectroscopic measurements, ground-based radar tracking systems, and Doppler analysis from Mars orbiters all confirm the same impossible narrative. Between September 23 to 26, 3I Atlas's velocity relative to the Sun decreased from 68.2 kilometers per second to 67.9 kilometers per second. Only a 0.3 kilometers per second change, not dramatic by any standard, yet statistically profound. Natural velocity fluctuations from measurement error or atmospheric interference typically scatter randomly. What we observe shows clear directionality, sustained deceleration maintained across multiple observation periods. Avi Loeb stated it directly in his recent analysis: "This is the smoking gun." Natural processes don't produce sustained deceleration at these velocities. Either we're witnessing exotic physics we fundamentally don't understand, or we're observing active propulsion from a technological artifact. 3 competing theories. If 3I Atlas is genuinely decelerating deliberately, what could explain such conduct? Theory 1. Reverse solar sail. Rather than using solar radiation to accelerate away like conventional sails, imagine positioning a highly reflective surface to function as a cosmic brake, creating resistance against the photon stream from our star. This demands exceptionally precise orientation, maintaining exact angles relative to incoming sunlight. Spectroscopic analysis reveals 3I Atlas possesses an unusually reflective surface, far more mirror-like than typical comet nuclei. The critical flaw: natural objects tumble chaotically. Random rotation should prevent sustained orientation. Yet 3I Atlas rotates with what observers term mathematical precision. Theory 2. Undetectable active propulsion. Perhaps electromagnetic drive systems generating thrust without visible exhaust or ion propulsion, so refined its emissions remain beneath our detection limits. The mysterious green luminescence surrounding the nucleus might represent ionized plasma manipulation, a propulsion byproduct we don't recognize. The challenge: power requirements. Any propulsion system altering velocity at these scales would require energy sources operating continuously for potentially millennia across interstellar distances. Theory 3. Precision gravitational navigation. The October 3rd Mars flyby produced measurable velocity changes. The scheduled March 2026 Jupiter passage offers potential for additional trajectory modifications. However, statistical analysis shows the timing is impossibly precise, occurring with probability below 1 in 50,000. All 3 frameworks converge on one unsettling conclusion: this isn't random cosmic debris drifting aimlessly. If 3I Atlas is braking, it's executing calculated maneuvers, not behaving like a tourist passing through, but slowing methodically, as if establishing presence, extending its observation period within our system. The pattern of escalation Oumuamua arrived first in 2017, accelerating mysteriously away, but that acceleration pointed outward in the expected direction. It displayed no tail or surrounding coma, remaining inactive during our brief observation window. Its elongated shape suggested a natural fragment. We tracked it for days before it vanished forever. It departed quickly, executing no trajectory corrections. 3I Atlas in 2025 decelerates, moving in the opposite impossible direction. It displays vigorous activity with bizarre chemistry, 95% carbon dioxide rather than the water vapor dominating every studied comet. Density measurements suggest a possibly hollow interior. We've observed it continuously for months. And critically, it adjusts its trajectory at key moments, threading past Venus, Mars, and Jupiter with statistically impossible timing. Oumuamua tested our detection capabilities. 3. Atlas is systematically testing our understanding of physics itself. Even Loeb's perspective has evolved dramatically. His statistical analysis now places natural origin probability between 30–40% down, precipitously from initial 90% estimates. The perihelion test, 13 days to truth. In exactly 13 days, we'll receive definitive answers. The perihelion test occurs October 29 to 31, when the comet reaches closest solar approach at approximately 1.36 AU, just inside Mars's orbit, subjecting it to maximum solar heating. Natural comets typically respond predictably. Catastrophic fragmentation from thermal stress, or massive tails as volatile ices explosively sublimate. If 3I Atlas survives perihelion completely intact, artificial origin probability jumps above 70%. If it decelerates again during this passage, executing another impossible braking maneuver, game over. We're no longer discussing natural objects. 3 scenarios. Scenario 1. Fragmentation. Breaks apart like conventional comets. Mystery solved through mundane explanation. Scientists worldwide breathe sighs of relief. Scenario 2. Survival intact. No fragmentation despite extreme thermal conditions. This strongly suggests internal architectural reinforcement, possibly that hollow core structure. The door to artificial possibility swings wide open. Scenario 3. The nightmare timeline. 3I Atlas uses perihelion strategically, executing an Oberth maneuver, deliberately exploiting the sun's gravity well to alter its path with minimal energy. This indicates intentional navigation and plans for extended residence. What comes next, beyond perihelion? December 19th marks our final premium Earth observation window. If velocity measurements continue showing deceleration, we receive our definitive answer. Then comes the March 2026 Jupiter encounter, another gravitational interaction opportunity, another potential trajectory adjustment. If it maneuvers again, artificial origin becomes undeniable. The European Space Agency's JUICE spacecraft will observe up close. We're witnessing real-time confirmation or denial of interstellar technology's existence. Unlike Oumuamua, which vanished before a thorough study, 3I Atlas grants us months to prepare for whatever revelation its behavior ultimately delivers. The bottom line: an object from beyond our solar system is behaving in ways that fundamentally violate natural physics. It's slowing when it should accelerate. Its timing appears deliberately precise when it should be random. Its trajectory suggests extended observation when it should represent brief transit. Whether 3I Atlas proves natural or artificial, it has already forced our collective consciousness to confront possibilities we've comfortably dismissed as science fiction. The universe doesn't owe us simplicity, but it does offer truth if we possess sufficient courage to pursue it honestly. October 29th will answer questions that have haunted humanity since Oumuamua first challenged everything we thought we understood about visitors from the stars. Somewhere in the black ocean between the stars, something began moving toward us quietly, steadily, with purpose. Not a meteor, not a comet, but a visitor. Now that visitor has arrived and is breaking every rule of celestial behavior we've ever written down. 3I Atlas, the newest interstellar object to enter our solar system, has become the most enigmatic thing ever observed in space. A 73 trillion pound mass racing at over 124,000 miles per hour, faster than any spacecraft we've ever built, heavier than 6 million starships combined. It is massive, silent, and precise. And most disturbingly, it is aligned. Its path slices cleanly through the plane of the planets within 5 degrees of the ecliptic. Its flyby of Mars last week, perfectly timed, perfectly measured, occurred with a statistical probability of less than 1 in a million if left to chance. Comets don't behave this way. Asteroids don't plan their encounters. But this one seems to. At Harvard, Dr. Avi Loeb has run the numbers, tested the models, and reached a sobering conclusion. there's a 30 to 40% probability this object isn't entirely natural. If it were engineered, he says, its trajectory would make perfect sense. Because if you wanted to study a solar system efficiently, to watch multiple planets, to observe life on Earth, you design a path exactly like the one Atlas follows. Now here's where it becomes unsettling. When Atlas passed Mars, the high-rise camera aboard the Mars Reconnaissance Orbiter was scheduled to capture the clearest images ever taken of an interstellar object. Scientists were poised to see the surface texture, the structure, maybe even rotation. And then, right on cue, NASA's data feed went dark. The official explanation, the government shut down. Somehow, the most sophisticated robotic observatories in the solar system lost the ability to transmit images just as this object made its closest pass. Even the European Space Agency confirmed that data exists, but their principal investigator cannot communicate the results. An unprecedented silence in the middle of the most important observation window in modern astronomy. Coincidence or choreography? Before the blackout, a handful of frames did make it through. Faint streaks, elongated, cylindrical, not the diffuse ball of vapor that comets display, but something smooth and coherent, like metal reflecting sunlight. NASA insists these are compositing artifacts, the side effect of long exposures. Yet the resemblance to the Navy's Tic Tac UAPs is difficult to ignore. Meanwhile, telescopes on Earth continue to record anomalies. A tail is forming, slowly, erratically, as though the object is deciding whether to behave like a comet at all. Polarization studies show an effect never before seen. Negative polarization at a 6-degree phase angle, meaning the scattered light reverses orientation instead of aligning predictably. The only way to explain this is if the dust surrounding Atlas is fundamentally alien, perhaps containing structures or materials unknown in our system. And that's only the first of 7 anomalies scientists have logged. First, the mass. At 73 trillion pounds, Atlas is far too massive for the interstellar medium to have delivered by chance. There simply isn't enough solid material adrift between the stars to fling something this big into our neighborhood within observable time. Second, the stability. Even as its surface releases gas, its trajectory remains rock steady, showing none of the tiny rocket effect nudges that push ordinary comets off course. It either has perfectly symmetrical venting, a physical impossibility, or it's under some form of control. Third, its composition. Instead of the frozen water typical of solar-borne comets, Atlas emits cyanide, carbon monoxide, and carbon dioxide in proportions that mirror planetary atmospheres more than icy origins. The environment around it looks Martian, not cometary. That implies formation on a rocky world, possibly ejected long ago, or constructed. Fourth, its resilience. On September 25th, a solar storm blasted it with charged particles powerful enough to strip an asteroid bare. Yet 2 follow-up observations showed no damage, no fragmentation, no surge in tail activity. It endured the event as if shielded. Fifth, its impossible alignment. Its orbit is not random. It tracks the solar plane like a spacecraft taking a survey of planets. It will pass near Mars, then Jupiter, then swing through Earth's neighborhood in December before fading into deep space. The probability of such precision by chance? Less than 1 in a million. Sixth, its energy. Racing at 150,000 miles per hour near perihelion, its kinetic energy rivals the yield of thousands of nuclear weapons. Nothing so massive, moving so fast, has ever been recorded entering our system intact. And seventh, its behavior in sunlight. Most comets brighten dramatically as they near the sun. Atlas seems to absorb light differently, scattering wavelengths in patterns inconsistent with any known minerals. To some, it's as if the surface is engineered to disperse energy rather than reflect it. When you line up all 7 anomalies, natural explanations start to fray. Loeb himself describes it as a black swan event, so unlikely that it forces us to re-evaluate our assumptions about what moves between the stars. During a recent press briefing, Loeb pointed out a haunting detail. 3I Atlas entered our solar system from a direction that aligns with the narrow cone of visibility from which an extraterrestrial civilization could have detected Earth's transit across the sun. The exact method we use to find exoplanets. In other words, whoever sent it, if it was sent, knew where to look. They could have discovered Earth's biosignatures thousands of years ago, waited, and then launched a probe timed to arrive when our technology matured enough to notice. It's a thought both terrifying and elegant, that the watchers have been watching us all along. If this sounds like science fiction, consider what we already know about human technology. We've built probes, Voyager, Pioneer, New Horizons, that will drift between stars for millions of years. If another civilization is even 1,000 years ahead of us, their probes might be common, disguised, indistinguishable from the debris of space. What better camouflage than to mimic a comet? Loeb calls this the Trojan horse hypothesis technology, masquerading as nature, the perfect stealth device, not a glowing saucer, but a lump of cosmic stone with just enough irregularity to pass as ordinary until someone looks too closely, and someone is looking. As Atlas approaches its perihelion at the end of October, observatories across the world are bracing for whatever happens next. Some expect it to brighten, fragment, and disintegrate like countless comets before it. Others suspect it will remain perfectly intact, sailing past the sun unscathed. If that happens, if it defies thermodynamics the same way it has defied probability, then we may have to confront the unthinkable. In November, the European JUICE spacecraft will have a chance to intercept its path near Jupiter, scanning for magnetic fields and structural features. But the data delay means we won't know the results until well after the encounter, perhaps not until it's already leaving the solar system behind. After December 19, 2025, Atlas will pass 167 million miles from Earth, then vanish into the outer dark. By then, whatever secrets it carries will be gone with it. A cosmic visitor slipping silently back into the night. Even if it's natural, its very existence forces us to admit something extraordinary. Interstellar space is not empty. It's alive with motion, with remnants, and perhaps relics of civilizations we've never known. And if 3I Atlas is not natural, if it's a probe, a sentinel, or a message, then we are no longer the observers of the universe, we are the observed. So, as it nears the sun, remember this: in a few weeks, we may witness either the most remarkable cometary event in modern science or the first confirmed contact with technology from beyond Earth. Either way, the sky will never mean the same thing again.